learn the mechanism of the Java program. We need to understand this content. So I'm going to show you a graphic. And then to give you a picture. The whole Java running what kind of process he is. Okay, let's open a diagram. On the drawing board. So let's write a Hello World program. Let's say this is our original file. Hello World.java. Okay, this is our original program, right? This is our original file. The original file. If we want to execute the original file, what system are we on? Are we on Windows now? Okay, this is Windows. Okay, so we're on Windows. If we want to run, do we just run it through him? Well, obviously not. What's the process? Does it have to be compiled first? Which means that we need to compile hello world.java. Compile to hello world.class. And this process is a compilation process. It's good to see. This process is a compilation. What is the result of this compilation? It's a compilation of bytecode file. What is the command used to compile? Is it JAVIC? Right, JAVIC command is okay. So the result of the compilation, it's a Word bytecode file. And this bytecode file can be executed if he wants to. Can it execute it directly in Windows? No, because Windows doesn't recognize the bytecode file. So what is it based on? There's a JVM in there. Attention, there is a JVM. So, do we have a JVM? Have we ever installed a JVM on the system? This is a what? He is actually a virtual machine. So this, as long as this JVM will be able to target our bytecode file to interpret and execute. Okay, so this step. We said that's what it is, explain and execution. In other words, JVM is actually a kind of interpretation to our bytecode file. One by one. What is the command he executes? We all know it's a Java command. So this is one of our basic execution process. Okay, then, here we find a point. Compilation and execution here need to have two environments. The first is JAVIC. And the other one is JVM. So for both of them to work, you need to look at: is it necessary to use these two? A JAVIC, that Java compiler in this piece. Where are they? It's all in our JDK. It's 11. That means we only need to download one JDK. Can we have both the compiler and JVM? Then the compiler is the environment provided by the JDK. JDK provides the environment in which JRE is applied, and we execute the interpretation, including the entire bytecode file loaded into JVM memory. So, in fact, we are using some mechanisms of the JVM. Mechanism of our JVM. If you have a MacBook, what do you need to download at this time? Do you need to download the support JVM for the Mac system? That is to say, you just need to download the JVM for your operating system. That's all. Okay, so the same thing. If you have a Linux system, because operating systems other than Windows, there can be other systems. Windows, Mac, Linux. Well, under different versions. I have a bytecode file. Can be executed on different by operating system. You just need to download the corresponding version of JVM. So, that means we have the same bytecode file. It can be executed on different operating systems. This time can be explained. So we have a conclusion. We only need to compile once. This Java file. It can be executed on different operating systems. It just needs download or install. JVM for a different operating system. It's just a matter of different operating systems. What is his characteristic called once compiled everywhere running? This is actually what it is, a basic principle of Java cross-platform. So in English it's called write once, run everywhere. Well, actually, it's pretty clear from our diagram. Because you only need to compile once to get to the bytecode file. And this bytecode file, it needs a different JVM. So for our Windows system, we only need to install the corresponding Windows JDK and we're done. If you want to use a MacBook on the MacBook, you can download the JDK for MacBook. For Java, the compiler for the facilities is universal. Different operating system can download a different version. It doesn't matter what platform you're on. I can use the same bytecode file. That just means that when I interpret and execute, I use a different JVM. It can be executed on any operation platform execution. So the mechanism is cross-platform. It has nothing to do with the platform. in comparison, like C language. His original file, where the hello world, is hello-world.c. While compiling, it is not compiled by JVM. On a different platform, it has different compilers. Such as C language and Windows compiler. The compiled results are available only on Windows. That's why we say that Java is cross-platform. Because the same bytecode file can run on any operating system. Because the bytecode file is platform independent. This is the cross-platform principle. For us to use it, just need to download the JDK of our corresponding operating system. Let's go back to the PPT. Look at the Hello World file. Then we open the Java editor. This editor is universal. As long as any operating system, the editor is universal. And the compiler will generate a bytecode file. It will be loaded into the JVM memory. At this point, it actually using JVM. And this JVM just need to download the corresponding version of the JDK. So this is the basic principle of cross-platform. We can use the diagrams to show for you. We can also look at some of the things were introduced in the PPT. There are different kinds of JVM, such as JVM for Windows, JVM for Linux, JVM for Unix and others. So based on the cross-platform feature of Java program, it effectively solves the problem of program design language on different operating systems. The problem of different machine codes greatly reduces the development and maintenance costs. So look at this chart, we all know some of his advantages. Okay, let's talk about the whole Java implementation process here.